I hope my screen is visible. I mean, my PowerPoint is visible to you all.
Yes, yes, it's visible. Yeah.
Yes.
So, data structures. Before data structures, we all know without data, any memory application, there is no meaning of any application or software in this world without data or any program. And what is that data? And I mean, where is that data stored and where is this program stored? All these programs and data are stored in external storage that we call hard disk. All that data is stored in this hard disk. And and to and whenever we need to access that data, CPU access that data to main memory. If you get access to that data in main memory through programs like linker, we all know whenever we write a program, like we have written C programs in our curriculums, and C source code goes to pre-processing, compiler, assembly, linker, and then loader loads it to the main memory. And when the loader links it to main memory, that data needs to be arranged in a particular order. And when we arrange that when in organized manner, the program's efficiency becomes more better. The data structure becomes more better. That's the arrangement of that data into main memory in an organized manner is the data structure. And in how many ways we can arrange that data in main memory? We can arrange in contiguous memory locations. Like here, we can arrange in such a way that it has one date, one open and one close, and we can arrange in a such a way that all data is arranged and have open ends for insertion and deletion. We can arrange that one data contains address of another data. We can arrange in such a way that are connected in network-like structure, in a hierarchical structure. Here, when we arrange data in a continuous memory location, like 0, 1 index, user index is there. It is called array. Here, it is a stack where data is stored in such a way that the first data element inserted will be the last one to come out. It has one open end. The last entered data will be the first one to get out, and it is called stack. In queue, we have both the ends open. Here we have one end for insertion of elements, other end for deletion of it. So the first element entered will be the first one to go out, and the last, I mean, yes, and the last one will be the last to go out. In here we have linked list, images linked list where our data contains the memory address of other data. We use concept of pointer here. This data is storing the address of other data, and like so on, they are connected. And last element will not store any address. In graph, it has data connected with vertices, and in tree, there are here we have hierarchical like structure, data stored in levels, and subordinate data items are there. So this is our overview of data structures. Let's move deep in this data structures. In computer science, a data structure is a data organization management storage format that enables efficient access of and modification. This is a Wikipedia definition. More precisely, a data structure is a collection of data values, the relationship among them, and the functions or operations that can be applied to that data. So, in general, way data structure is all about dealing with structure and structuring and storage of data. Like we are building flowcard application here, and we have lots of data coming from server, and we structure that data to array lists and maps, dictionaries before presenting to the user. So data management makes data management easier in the sense. So here some examples of data structure are arrays, linked lists, stack, queue, trees, etc. Data structure are widely used in most every aspect of computer science, that is compiler design, operating systems, graphics, artificial intelligence, and many more. You can have a look. I have shown this picture already. We will be going through this data structure topic. In this data structure topic, we will going through these data structures. So before going more further, we have to know some basic terminologies in relation to data structures. There are first terminologies would be the data. We have talked about this. We can define data as elementary value or a collection of value. For example, employee name, ID, all these are single data. Data items, single unit of value. This single unit ID is a data item, name is a data item, gender is a data item here. Group item, data item that have subordinate data items are known as group items. Like an employee name have subordinate items like start name, middle name, last name. These are you can group this name into group items. Elementary items is something which cannot be undivided, which cannot be divided. Like we divide this name into group items. Elementary items like ID, you can't divide this into further subordinate items. Entity and attribute. This whole data collection is a one entity, and it has its attributes like ID, name, gender, job title. Like we have already made an entity, like when we make classes in program, we make an entity of data. It's written a class of certain objects is represented by entity. It consists of different attributes. Each attribute symbolizes a special property to that entity. So this is basic terminologies. Let's move further. What we have here, and why do we need data structure? I have talked some about it, but let's see this. As applications are becoming more complex and amount of data is increasing every day, which may lead to problems for data searching. Data searching in data searches, we apply operations, that is data searching, processing speed, and multiple request handling, and many more. So data structures support different methods to organize this complex data and manage this complex data and store it efficiently so that we can perform operations in it like insertion, deletion, searching, selection, sorting. So data structure make these operations more efficient. Uh, Classification of data structures. We can classify data structures into categories: primitive data structures and non-primitive data structure. So here I have a picture representation of data structure categories. One and it is written primitive data structure, another and this is non-primitive data structures. You have already aware of integer, float, character, boolean. Non-primitive have linear data structure and non-linear data structures. It is written wrongly here, but it's non-linear data structure. And linear data structure can be further divided into subcategories like static and dynamic. We have arrays in static and dynamic, linked lists. In dynamic, we have linked list, stack, queue. You can have a look in this picture. Now let's move to primitive data structure. Primitive data structures are data structures consist of numbers, characters that come in built into programs. These data structures can be manipulated and operated directly by machine level instructions. That is why they are called primitive data structures. Basic data types like integer, float, character, boolean come under this primitive data structure. And they contain characters that can't be divided further characters. These are mainly simple data types, but we have already covered in data types. Let's move further to non-primitive data types, data structures. Non-primitive data structures are those data structures derived from primitive data structures. These data structures can be manipulated, operated, can't be manipulated directly by machine level instructions because they are built upon it, built on primitive ones. The focus of the data structure is on forming set of data elements that is either homogeneous or heterogeneous. And homogeneous is something that stores data of same data type like arrays. Heterogeneous, which store different data types, which will we will talk about more about this. Based on structure and arrangement of data, we can divide these data structures into two subcategories. So non-primitive data structures can be divided into two more subcategories that are linear data structure, as we have seen in this diagram. Non-primitive will be divided into linear data structure and non-linear data structure. So in linear data structure that preserves a linear connection among its data elements is known as linear data structure. Arrangement of the data is done linearly, where each element consists of successors and predecessors, except first and last element. So these are data structures which are arranged in a linear fashion. Like array, like array is arranged in a linear fashion in a contiguous memory location. So these are linearly arranged arrays. I mean data structure. But when you see tree, these have data data arranged in different levels. They are not arranged in a continuous fashion. Let's move to slide that I was in. So when we say arrangement of data, it doesn't mean we have to arrange that data in that memory fashion, as arrangement may not be sequential. Like linked list is a linear data structure, but not arranged in continuous memory location. We know one data element contains the address of other data elements, and other data element can be stored in some other memory location. But in array, we have contiguous location. So when we say arrangement in linear fashion, we don't necessarily focus on memory here, memory allocation here. But data structures based on memory allocation can be divided into furthermore categories that I was talking about, static data structures and dynamic data structures. Let's see what's written in this slide for this. Based on memory allocation, data structures are further classified into two types that are static data structures and dynamic data structures. Let's see what's written in data structures, static data structures. The data structures having a fixed size are known as static data structures. The memory of these data structures are allocated at compile time. Compile time is a time at which source code is built into executable code. The size can be changed by user after being compiled. However, data stored in the item can be altered. Array is the best example of static data structure. Dynamic data structures. The data structures having dynamic size are known as dynamic data structures. Memory of these data structures is allocated at runtime. Their size varies during runtime as of the code. Moreover, the user can change size as well as data elements stored in this data structure at runtime, like linked list, stack, queues. Let's move further. Nonlinear data structures. Nonlinear data structures are data structures where the data elements are not arranged in sequential order, like in trees and graphs. There exists a hierarchical relationship between individual items, as we have in trees and graphs. Types, nonlinear data types are trees and graphs. Let's move to what are the basic operations of data structures that we do. Here are traversal, search, insertion, deletion, sorting, merge, create, selection, update, splitting. These are operations we do in data structures. On the data we store in a sequential order. Uh, for these operations that we have structured our data in arranged manner. Let's see more about these data operations. Traversal. Traversing a data structure means visiting the elements stored in it. It just means getting access to the date to the to the elements that we have stored in data structure. It is traversal. Search means to find particular element of that given particular element in a given data structure. When you have to find an element, you perform search operation. Insertion simply means addition of any element in a data structure. Deletion is as simple as it is written deletion, delete an element. Sorting data in a particular order means you want to sort the your data structure in ascending or descending order. Then you perform sorting. Uh, yeah. These operations help to do further processing, makes processing easier. Merge, merging data of different order, merging data of two different orders in a specific order, maybe ascending or descending. So we merge two different data orders. We create create is an operation used to reserve memory for the data elements. When we create, we allocate some memory. That is what creating is. Create a data structure. Uh, Selection, it selects the specific data from present data. When you want to select in data structure, you perform selection operation. When you want to update, here ninth number is update. When you want to perform update on the data present in your data structure, you will perform update, splitting, dividing data into subparts to make process complete in less time. Those many times when you do search operation, you split the data and perform your operations. So these are the operations, uh, basic operations that you can perform in data structures. Now, so as far we have studied, a data structure is an arrangement of information generally in the memory for better algorithm efficiency. And from the definitions we have mentioned in previous slides, we can conclude that operations in data structures include addition, deletion of an item from a list, searching, sorting an item in a list, accessing an element in a list. And whenever we do such operations in our data structure, it is known as abstract data types. So all these operations, when we perform all these operations in our data, when we can perform these operations in our data structure, it becomes an abstract data type. And all the data structures like array, linked list, queue, stack, etc. are examples of abstract data type. So as far as we have studied till now, we have studied about how data is accessed by CPU into main memory and in an arranged manner. That's what we call data structures. And we have these types of data structures: arrays, stacks, queues, graphs, linked lists, and both have this. Each have their own properties. In array, we store in contiguous memory location. In stack, we store in such a manner that its one end is closed, another end is open, and the first element which would be entered will be the last one to go out. In queue, we have such that both the ends are open. We can add the element from one end, and I mean, we have addition from one end, deletion from other end, and the first one will be the first one to go out, and the last one will be the last to go out. And here, linked list, one element stores the address of other element, and such on. We talked about basic terminologies like data, data items, group items, elementary items, entity attributes. We talked about why do we need data structures to solve the processing problems related to complex data. We perform data structures. We have two different types of data structures: primitive data structure and non-primitive ones. Here we have shown that we have seen the diagram, everything in the pictorial format. Primitive data structures, int, float, character, we all know this. Non-primitive data structures, which is further divided into linear data structure and non-linear data structure. Arrays, trees, arrays are some linear data structure, trees, non-linear data structure. And linear data structure can be further divided according to memory allocation in static and dynamic data structures. Static is array, dynamic is linked list, stacks, queues, because we allocate memory dynamically at runtime. Here we allocate memory at the compile time. Nonlinear data structures, which are some data which are not arranged in a sequential order, like happens in linked list or arrays or queues or stacks. And nonlinear data structures have its types, trees and graphs. Operations, we talked about some operations, and we got to know about this that when such operations are possible with this data structure, it is called exact data type. So my part of the session is going to end here. If anybody has any question, they can raise it. We will move next for the session with Siddharth. No questions? Siddharth, you can take the control now. Okay. Thank you, everyone. I'm stopping the share here.
Thank you, Vishal. Thanks for the session.
Thank you, sir. Is my screen visible?
Hello.
Yes, it does. It's visible.
Yes. Okay. Good morning, everyone. Today I'll be dealing with the topic of arrays in data structures. So basically, what are arrays? An array can be said as a collection of same data type stored at contiguous memory locations. By same data type, I mean that if when we are creating an array, suppose we created an array of data type int, then our array will only have that data type present in it. Like it cannot store string values or float values or anything else like that. It will only have integer data type or of string data type. And at contiguous memory locations, it means that uh, like when we create some data, it is stored in our main memory of in the main memory of our system. So when we are creating an array, it is basically a list of data, and that data is stored uh, it's stored one after the other in our memory location. Like suppose if our uh, value at index 1 is supposed in the computer memory location at x, then the value at index 2 will be stored at the computer in memory location near 2. Generally, generally arrays have a fixed size, and if the size is defined, then we can neither increase nor decrease the size. This is one of the main disadvantages of arrays. Like if we declare an array of size 5, then it should have at least 5 elements present in it. And if we want to increase its size, then we have to create a new array and store the previous values in it. Arrays help us to traverse and manipulate data easily with the help of iteration. Like if we want to extract any data or search for a data present in our array, we can use for loops for doing so. Now, here we have declaration of an array in C hash. So this is the basic syntax for declaring an array in C hash. We mention the data type, we give the variable name, and our and an array should be enclosed within curly braces. If I have a code present here, how to do so? Like this is my main class, and here I have created an array ar of in data type which has 5 elements in it: 35, 50, 55, 77, 98. This is how we declare and define an array. Now we have array declaration and operations on array. So this is how an array looks like in C hash. This is an int array, this is a string array. We can access and update elements of an array at a given index. For example, this is how we access an element in an array if we know the index, and this is if and here we are accessing the value present in array 1 at index 3, which is 4 in our case. Now for updating the value, like this is our array name, this is the index given by us, and now we can see that at index 2 the value was 3, but now we are changing into 10. So after updating the value, we can when we print the array, we can see that the value has been updated. Right. And this is the program for creating an array where each and every element will be user inputted. Like we will be deciding which values we want our array to contain. So here is our array one of integer type of size n. I have defined the size as 5. Now we will be entering the elements in our array using for loop. Here in this for loop, we are going through each of the value present in our array, and then we are inputting the values in it. And after that, with the same for loop, we can see all the elements present in our array. For example, like I run the code and now it's asking me to enter the values at index 0 in our array. So let us say I 20. So if all the values are in data type as I've declared it to be int, there is no errors and the array is created successfully. And apart from this, we can also delete an array. We can also delete an element present in an array by giving the position at which the value is present, which we want to delete. So for doing so, like this is my array and these are the values present in it. Suppose we want to delete an element which is at position 2 in our array, which means 55. So we will run a for loop in which we will give the position which we want to delete our and then iteration will start. Uh, when we reach that index, we will remove that item from there and the element next to it will come at that place and the size of the array will also decrease by doing so. So this is how deletion in an array works. As you can see, first it had 5 elements present in it. When we deleted the element at index 2, now it only has 4 elements present in it. So this is how insertion and deletion in an array works. And we can even update an array we know at a given index. Like this is a program for an array of string values. Here I have a string array of 3 values and now I will this is string. Like in this array we have created a new string array of 3 values, hello, bye and see you. And first I've shown the what is the value of and what is the value at index 1, and as we can see at index 2 I had given the value cu, but now I have changed the value of index 2 from cu to now, and if I check it then it has updated over there. So this is how we can update manually elements in an array. Now we have time complexity of an array. So when we are using the index value, we can access the array elements in constant time. Thus, the time complexity of an array for a given index value is order of 1. And when we need to traverse through an array and go through each element, then the time complexity increases. Thus, in that case, the time complexity becomes order of n. And these are the basic advantages and disadvantages of arrays. Like arrays helps us in code optimization, and by code optimization, I mean that uh, it helps us to write less code and more efficient code. It is of random access. It helps us to traverse and manipulate data easily, as I've shown, and we can easily sort data in an array. And one of the main disadvantages of arrays is that it is of fixed size. That's all for this session, I guess.